Hey everyone, today we're jumping into one of the coolest ideas in matrices, the determinant. Now I know what you're thinking, probably another messy math calculation, right? But what if I told you it's not really a calculation, but more like a single powerful score for a matrix? A number that tells you pretty much everything you need to know. Okay, let's get into it.
So, think about this for a second. You take a photo, you pull it up on Instagram or Snapchat, and you slap on a cool filter that stretches or maybe warps the image a little, and then, you decide you don't like it. What do? You hit undo, right? And poof, everything's back to normal.
Well, that action, applying the filter, can actually be represented by a matrix. And that undo button, that's just the inverse of the matrix. But here's the catch. Not every action can be undone. It turns out there's one single magic number that decides whether that undo button is even going to work.
And that magic number? It's called the determinant. So the official NCERT definition says for every square matrix A, we can associate a special number, which is its determinant. We write it as det A, or we can put these vertical bars around A, kind of like the absolute value symbol. But the most important thing to remember is this. It's a scalar, a single number, not another matrix.
So what's the first and, honestly, the most important job of this number? Well, you can think of it as the ultimate pass/fail test for a matrix. It tells you the single most critical thing about it.
And check this out. This is what makes it so simple. If the determinant, our matrix score, is anything other than 0, it's a pass. That means the matrix is called non-singular, and whatever it does is reversible, it's invertible. That undo button works. But if that score is exactly 0, it's a fail. The matrix is called singular. The action is permanent and you can't undo it. This also tells us if a system of equations has a unique solution. So the real question is always, is it 0 or not 0?
So this leads us to the formal definitions you'll see in your textbook. A square matrix, A, is called non-singular if its determinant is not equal to 0. And it's called singular if its determinant is equal to 0. That's it. It's as simple as that. This is a super important concept, so make sure you got it locked in.
Okay, so we get it. 0 is a huge deal. But what about all the other numbers? What if the determinant is 2 or maybe -5 or 100? Well, the number itself has a really cool meaning too. I like to call it the geometric virality score.
The absolute value of the determinant tells you the scale factor of the transformation, and a transformation is just the action the matrix performs on a shape or on space. So in simple terms, the determinant tells you by how much the matrix stretches or shrinks things.
So for example, if you apply a matrix transformation that has a determinant of 3 to, say, a square, what happens? The area of the new shape will be exactly 3 times the area of the original square. It literally scales the area by a factor of 3.
A really great way to think about this is like a video's virality score. A score of 10 million means it reached a massive audience. A high determinant means the matrix transformation has a huge effect. It really amplifies the space it's working on. A small determinant means a smaller effect. It's basically the impact score of the matrix. All right, now for the important terms and conditions. A lot of students get tripped up on a few key points here, so let's clear them up right now. I want to make sure you don't fall into these super common traps. Okay, let's run through these real quick so you can avoid these mistakes. First, the determinant is a single number. It is not the matrix itself. Second, you can only find determinants for square matrices. This rule is a big one. Third, a determinant of 0 is not an error. It's actually a super useful result that tells you the matrix is singular. And finally, nope, determinants can be negative. We'll get to what that negative sign means in just a bit.
And hey, just a quick history fact for you. This idea wasn't just invented for a math class. Mathematicians like Laplace and Kramer actually developed this concept to find a systematic way to solve real-world problems, especially systems of linear equations, so it has a very practical origin.
So let's bring it all back together. Why do you need to master this score? Why does it matter so much? Because it's not just one topic. It's the key that unlocks a bunch of other really important chapters. Check out how this one concept just builds and builds. First, you absolutely need the determinant to find the inverse of a matrix. Remember, no non-zero determinant, no inverse. Simple. Second, it's the foundation of Kramer's rule for solving systems of equations. And third, you can even use it to find the area of a triangle just by knowing its coordinates. See, this one idea is connected to everything.
All right, time for a super quick recap. Here is your determinant scorecard. Remember, it's a single number, a scalar. It's only for square matrices. If the score is 0, the matrix is singular and not invertible.
If the score is not 0, it's non-singular and invertible. And its absolute value is that geometric scale factor. It's virality score.
And that's pretty much it. If you can really master this idea of a single score for a matrix, you have truly unlocked one of the most fundamental tools in both algebra and geometry. This stuff is way easier than it looks, and you're doing great.
So I'll leave you with one final thought to chew on. We know a determinant of 3 makes a shape 3 times bigger. But what about a determinant of -3? What could a negative virality score possibly mean for a geometric shape? Think about it, and we'll explore that next time. Thanks for tuning in.